Good morning, this is Miss Billerbeck, and we're going to talk about 2.4 parallel lines and perpendicular lines. So first, let's take a look at Desmos. So when we take a look at Desmos, we see we have a slope-intercept line here with a slope of 1 and a y-intercept of b. Okay, you probably want to move this one off, so I'll talk about that green line a little later. Okay, so when we have a slope-intercept of b equals 0, it's right through the origin. So we might see a line like y equals 2x or y equals 3x, and that's b equals 0. Then you may notice I have another line that is a very similar format, but with a C for a y-intercept. So let's take a look at what might happen. So as I change the y-intercept, the lines become separated, but they have the same slope. And we call these lines parallel lines. All right. So we'll take that back to the 0 here. Let's see if I can get it right on the 0. There we go. Now let's take a look at this green line here. So if I have the green line, I have a negative inverse of this slope here. Now, when I change this over, you can see that I have something here. Now, if I change the slope, we can identify what this angle is. So let me change the slope and we'll see what the angle is. Now, we know that there we go. We know that the axes meet at a right angle. So if I set this up where m equals 0, then the two lines are meeting at a right angle. So if I go back and set this at 1, we see, oh, these are at a right angle. Okay, when two lines intersect at a right angle, they're called perpendicular. So we have a negative inverse that would make that perpendicular. Now, let's say we didn't have a negative for a moment, and let's see what would happen. Okay, so the line ended up on top of the other line. Let's take a look at what happened. That is not what it should happen. Okay. Oh, that's because m is 1. Now let's make m not 1. I was wondering there. I'm like, that shouldn't happen. Okay, so that's if m is 1 because 1 over 1 is 1. Okay, but now let's change it. Oh, look at that. So if m is 3, it is no longer parallel. I mean, no longer perpendicular. But as soon as I put that negative back, let's see if I can get it right there. Look, I'm back to 90 degrees. All right, so the reason being for that is that if I'm in this quadrant, I have positive x's and positive y's. But if I'm at the adjacent or next to quadrant, say 4, I have a positive x and a negative y. So this slope, as x increases, decreases, so it's a negative slope. Okay, if I look at quadrant 2, which is adjacent to this quadrant, where perpendicular lines are going to end up in different quadrants because they're at right angles. So this is a negative x and a positive y. So as x increases, y is still decreasing. So I have a negative slope in this area. And then what's next to 2 and 4 is quadrant 3. And we can see we have a negative x and a negative y. Two negatives make a positive. So as x increases, y increases. So we have a positive slope. So we have a situation here where there's no way for the two perpendicular lines to be in the same quadrant at the same time. So they have to be negative. One has to be negative and one has to be positive. whether it's the first equation or the second equation. One of them must be negative. All right, let's go back to our lesson here. All right, so let's look at what we just learned. Okay, so if we're looking at an equation that is a y equals mx plus b, which is our slope-intercept equation that we were looking at in the graph, we see that parallel lines have the same slope. Okay, so slope. So that means m1, the slope of the first line is going to equal the slope of the second line. Now, perpendicular lines have negative reciprocal slopes. So this little fancy upside down T right here is our shorthand in math for perpendicular, which means they intersect at right angles. So the perpendicular slope then will equal the negative reciprocal of this slope. And if this slope equals this slope, it's also equal to the negative reciprocal of 1 over m. All right, so let's take a look at this equation. So what is the equation of the line in slope-intercept form that passes through -3, 5, and is parallel to y equals -2/3 x plus 3? So we don't really care about this one here. It's the y-intercept. Or we shouldn't need to. I'm going to practice that. Okay, so this is what we care about, the slope. So this one's the slope. And we know that the parallel lines, which they're asking for parallel, so slopes are the same. So the new line slope will be -2/3. Now there's two ways we can do this. We can do this with the point slope formula, y minus y1 equals m times x minus x1. So that's the point slope form. Or we can do y equals mx plus b. So we'll do it each way. Now, if I use this one for my x1 and this one for my y1 in this point slope, I have y minus 5 equals, and then I put this parallel slope, which is the same, 2/3. Let me make that a nice 2/3. -2/3, and then I'm going to have x minus, and then the x is -3. Okay, so I can make this a positive, or if I already know that when I distribute this here, this -2/3, and I distribute it to each, I see I have 1, 2, 3 negatives to deal with. So I know one negative makes a negative times a positive makes a negative, and a negative times a negative makes a negative. But what is a negative times a negative times a negative? So if I can come up with that, I can save myself a step. Okay, so actually, if I ever have 3 negatives multiplying, an odd number of negatives, let's even make it more general, the number will be negative. Okay, and if I have an even number of negatives multiplying each other, the answer will be positive. So I can skip the next step that I'm going to write. So right now I'm going to say 5 minus -2/3 x. I'm going to actually do plus 3 just to make it easier. And then when we distribute this, now if we didn't see the other step, we have y minus 5 equals -2/3 x, and then 2/3 times 3 over 1 is just -2. So we have -2. Okay, so we could have just gone straight to this from right here had we known a negative times a negative times a negative is going to be a negative. All right, so we're not quite done with this because we need to move that 5. So it's a -5. So what I'm going to do is I'm going to add 5 to both sides. So 5 minus 5 is 0. So that gives me this formula, y equals, and then -2/3 x, and that's a 2/3. And -2 plus 5 is 3. Okay, so let's try it with this slope-intercept. We just did the point-slope form, so we have now gotten our slope-intercept form because it wanted the slope-intercept form that passes through -3, 5 and is parallel to this. So this is slope-intercept form, and we have the same slope, and we'll address something in a second. Okay, so we have y here and x here. Well, we can just plug in this y, the 5 right here. We can plug in this slope here. And we can plug in that x, -3, and plus b. So we're trying to find a y-intercept right now, so because that's the only thing missing in this slope-intercept equation, because I know slope, x and y are variables, and I need to know b. So this cancels, the negative cancels. So I have 5 equals, and then that's just 2 plus b. When I subtract the 2 from both sides, I get b equals 3. So when I substitute that back in here, I get this very same equation here. So y equals -2/3 x plus b. Okay, so the slope, -2/3, the y-intercept, 3. So I can do it either way using point slope form here, or I can use this form right here, the y equals mx plus b. But now I need to address the problem here that has happened. So we were asked to create a parallel line, and we know parallel lines have the same slope. And that's what we did. But if you look closely, and I said, well, you don't need to pay attention to this y-intercept when you're trying to do this. And then this y-intercept and this y-intercept are the same. Well, that means they infinitely intersect on this line. So parallel lines, the definition is that they never intersect. So have we created a parallel line? And is it even possible? So this point apparently is on this line, and I've created an equation that's the same in two different spots. That's the same equation as that, but in point slope intercept form, or point slope form. This is slope intercept form. So I have the same equation. So what I've created is not parallel lines. So it isn't possible. So what I've created is coincident lines. So these are coincident. Okay, so it is not possible. So if I erase this here, my answer then will have to be not possible. Because they're coincident. That means they're the same line. Okay, so they can't be parallel. All right, so let's go look at something else. Okay, So what is the slope of line A? So we have line A here. So we want to look for places on line A that intersect with the grids. Okay, so there's several of them. So what we're going to do is we're going to rise up. I'm rising up 3, and I'm running 1 right here. So if my slope is the rise over the run, then I just count, say my rise is 3, my run is 1, so my slope is 3. So that's the slope of line A. So if I look at what is the slope of line B, well, I do the same thing. I find where does it cross. So I see it crosses here and here and here. So I look at that and I see, oh, it rises -1 and runs 1, 2, 3. So my slope here, my rise and my run is -1 over 3. So that means that my slope for B is going to be -1/3. So I look at the slopes and I see, oh, that's 3. That's -1/3. So I have perpendicular slopes. That means that that's at a right angle. And we've already explored this. Why are perpendicular slopes negative reciprocals? We saw that with the Desmos, that if one of these lines is going to be at a right angle of another line, as soon as we rotate it off of the axes, they're in different quadrants. So one has to be a positive slope, one has to be a negative slope if they're going to be at a 90-degree angle or perpendicular to each other. All right, let's look at the next problem. So let's write the equation of the line that passes through the point 4, 5 and is perpendicular to the graph of y equals 2x. So what that means is my perpendicular slope, if this is the slope here, then my perpendicular slope will be -1/2. Okay, so now I can use the point slope, which is pretty simple to use, and it's not specifying why the slope intercept, so I can get away with the point slope one, which is very easy. So if this is x1, y1, I have y minus 5 equals -1/2, and then I'm going to do x minus 4. And I'm done. That's all. That's the point slope form. It just asks for an equation. That's an equation. Okay, but if I wanted to do a slope intercept, then what I can do is write y equals mx plus b. Put the x in here, put the slope in here, put the y right here, and the only thing I don't know is b. So I have 5 equals -1/2, x is 4, and b is b. So we are finding that one out. So we have 5 equals -2 plus b, and we add 2 to both sides, so we get b equals 7. So our new equation will be y equals -1/2 x plus 7. We can quickly check that if we put 4 in there. -1/2 of 4 is -2. -2 plus 7 is 5. So this one, I'm going to make some room here, is the slope intercept form. Okay, so we have 2 equations that we can make, the point slope form and the slope intercept form. Okay. Great. Are the graphs of the equations parallel, perpendicular, or neither? Well, let's identify the slopes, because we know that is the key to this question. So that slope 1 is that, slope 2 is 1/2. Are they parallel? Not parallel, because they're not the same. Okay, are they perpendicular? Well, they're reciprocals, but they're not negative reciprocals, so not perpendicular. Okay, so they are neither. So don't think, oh, they're reciprocals, that they're one of two, that should be enough. No, it is not enough. They need to be negative reciprocals. Okay, now let's look at this one. So we have this slope, m1 is -5. Okay, now we can rearrange this equation, and we can move this over here, 25x, and do -25x here. Now, I must say, this is not a like term to 1, so do not add 1 to 25, okay? Please do not. So we have 5y equals -25x plus 1. Okay, I still don't have y by itself, so I divide by 5. And I get y equals -5x plus 1/5. So slope 2 is -5. Now I was trying to work with a scholar, and they said, well, Miss Billerbeck, you can get the slope right here. So if you take the slope and you take the coefficient of y, b, and put it over the coefficient of x, a, then you get the same thing. Although this is a negative, so we have to remember that there is a negative there. So we could do that, okay? But we have to remember to put a negative sign here. So, so if we have a -25 over 5, and that would be a simple route to go, then we do get -5, okay? Because that's what we're ultimately going to do. But because this is on the same side as that, we have to move it over here, which makes it a negative, okay? So that's another way. Now we haven't answered the question though, okay? So the slope of 1 equals the slope of 2. So do we have parallel lines, perpendicular, or neither? They are the same, so they are parallel lines. Okay, as opposed to this one was neither. Okay, so we have the last slide here. Okay, so if we have the equation y equals 2x plus 7, and it represents the north path on a map. Okay, and we want to find the equation for a path that passes through 6, 3 on this very map, but is parallel to this line. So the fact that it's parallel gives us a clue that the slope of this new line is going to be 2. Okay, we can use the fact that this is x1, y1 and create a point slope. So we have y minus y1, which is 3, equals 2 times x minus 6. And they didn't say slope intercept, so that would work. Okay, but this one is in slope intercept, so if we wanted to do it in slope intercept, we would just use this y, 3 equals that slope, 2 times x, which is 6, plus b, that's a 12, so we have 3 equals 12 plus b, And now we're going to subtract the 12, and we get -9 equals b. Okay, so with all that, we now have the other equation, y equals 2x and then -9. We can check it really quickly. X is 3, so 2 times 3 equals 6. I'm sorry, put 6 in here. 2 times 6 is 12, -9 is 3. Whew, that was a mistake. Okay, and then here I've got 6 minus 6 is 0, so 2 times 0, and y 3 minus, well, we did point slope, so of course those two are going to be 0 because we put that in and that in. All right, so we have our two equations right here. Okay, one's in point slope and one's in 2x minus 9. Okay, so if we want to find the equation that's perpendicular, then we just change the slope of this one, y minus 3 equals, instead of 2, the perpendicular slope is going to be -1/2 because it's the negative reciprocal of that one. And now we just do x minus 6 and we're there. It would be lovely if it was just that easy for that one, but it's not. So let's go back to this. We're going to put y is 3 equals 2 times this. Whoops, it's not 2, it's -1/2. -1/2 times 6 plus b. So -1/2 of that is 3. So we have 3 equals -3 plus b. So when we add 3 to both sides, we get b equals 6. Okay, so now we have b equals 6 because that's 0 and that's 6 and b is just that. So now let's write the slope-intercept form will then be y equals -1/2 x, and then it will just be plus 6. That 1/2 is hard to read, so let me write that a little better. 1/2, and that negative should be with the fraction bar. Okay, so those are the two equations that we could write for the line that's perpendicular to the north path and goes through that point. So we can check this point again. -1/2 of 6 is -3. -3 plus 6 is 3, and it's a check. All right, I hope you have a wonderful day. Bye-bye.